All right, so this series of lessons is on function notation. And the reason, well, what that is, right, is just the f of x to represent functions instead of a y. The reason this is all useful is because it allows me to give functions names and allows me to do things like this. I can be like, well, if f of x is this, f of negative 2x is what, you know? So it's just a different way of writing down functions. It's still a little bit less familiar to us than using y, but it is more useful in it's more useful in big boy math to write things down this way. Okay, so f of anything means plug in anything for x. So what I'm going to do is I'm going to rewrite this function. So I have x plus 3 halves x squared. But every time I have an x, I'm going to leave a little space. And then in that space, well, I'm writing in negative 2x. So I get negative 2x plus 3 halves negative 2x squared. Negative 2x is just chilling. And then I PEMDAS, right? So we're going to square it first. And negative 2 squared, negative 2x squared rather, ends up being 4x squared. So I get 3 halves times 4x squared. And then my result is negative 2x. I'm just going to simplify. So 3 halves times 4 would be 12 over 2, which is 6. So 6x squared I get there. And these are not like terms, so I'm going to leave them alone. And that is f of negative 2x. So I just replaced every x with a negative 2x and then simplified. That's my result. Here, f of x minus 3, so I have a new f of x. This is easy. So f of x minus 3 means, well, I take f of x, which is negative x squared minus 3x, and then I subtract 3 from it. That's it. That's f of x minus 3. Okay. So I just substituted in the function for f of x, and because this 3 is outside the function, I'm not plugging it in. That's all that means. So neither of these things are rocket science. Both times the hardest part is probably simplifying, so work carefully as you simplify.